Morning students, I hope you all are doing good. In the previous video session you have gone through the meter bridge, and today let us see about this potentiometer. Actually, this is one of your practical. We are comparing the EMF of two cell by using this potentiometer. This is one of your practical topic, and we have this instrument in our laboratory. So just we will go through this. First thing, this is just a construction of this potentiometer. Potentiometer means, first thing we have to know what is the use of this potentiometer. So you see the potential difference, current and resistance. These three things we can accurately measure by using potentiometer. So that is the use of this potentiometer. So the potentiometer is used to measure accurately the potential difference and the current resistance. So that is the first thing we have to know about potentiometer. So easily you can measure the potential difference between the 2 points by using this potentiometer. Current you can measure accurately, resistance you can measure accurately, and how it is constructed, that is what the next thing we are going to see. Actually, you see, it is like you can see that the diagram is looking like something like meter bridge only, isn't it? So here diagram only half part is given. Actually, this potentiometer, it consists of a 10-meter long wire. There we have seen in meter bridge 1 meter wire, 1 meter length, and here we are using 10-meter wire. 10 meter, its length is 10 meter. 10 meter means we know that it is very big. It is equal to 1000 centimeter. So, and this 10-meter long wire, which is made up of manganese, or you can tell that the constant in stretched wire. It is what you can tell that unstretchable wire. That is what it is made up of manganese or constant. And how it is made means, in parallel rows it is fixed like this. First row 1 meter, then this is second row 2 meter, now third row like this. This is how it is constructed. 3 meter like this. You can see 4 meter, then what 5 meter, 6 meter, 7 meter, 8 meter, 9 meter, then 10 meter. You see, like this you can see 10 rows. 10 rows are all parallel rows you can see. So this is how a potentiometer wire is fixed on a wooden board. And you can see that two free end. This is one end and this is another end. These two free end, you can keep it as A and B, are brought in the same side. You can see that this is a two free end of this 10 meter long wire, and both this free end which is brought on a same side, and this two end which is fixed by using a binding screw. We know that in the laboratory going times we will explain clearly. By seeing that instrument you will understand this construction. And what happened means, along with this 1 meter scale, on that same wooden board 1 meter scale is fixed like this, 100 centimeter. So you know that 100 centimeter, 200 centimeter, 300 centimeter, 400 centimeter, 500 centimeter, 600, like this we will take the reading also. And a jockey is provided. Okay, one jockey also provided, so that we can make a contact. So here you can see. So here 10 rows will come, okay, like this, 1 2 3 4 5 6, and like that 10 rows will come. Here just one row they are given as CD. Now what is the principle? So I believe that you understand that construction. First thing you use, what is the use of? Accurately we can measure the potential difference, current and resistance, and how it is made up of. Yeah, it consisting of a 10 meter long manganese or constantin stretched wire, which is arranged parallelly in each row 1 meter length and fixed on a wooden board. You can see these two free ends. These two free ends are what are brought two ends. You can keep A and B. These two ends A and B are brought the same side and fixed with binding screws on this wooden board. And a meter scale. There is a meter scale also fixed parallel to this wire, and also a jockey. This is what a jockey. A jockey is provided to make a contact. That is what the first thing. The next thing is, what is the principle? Let us see what is the principle of this potentiometer. The first thing is, assume that some current is passing through this wire CD. CD means any of this row. You can just example here given CD. Assume that there is some current passing through this, and here you can see battery on key and this potentiometer wire. These three things are connected in series. It is what we can tell primary circuit. Primary circuit. So what are the things connected in the primary circuit? A battery, key, and the potentiometer, which is connected what are in the form of a primary circuit. And you can see this positive terminal of the battery. Then what are battery is connected at this point C. Then what are negative terminal? You can see this negative terminal. You see a battery, another battery also connected. This is a primary circuit. In this primary circuit, a battery, key, CD wire. This wire, these three things are connected in series and forming a primary circuit. And this is what a secondary circuit we can tell. Secondary circuit. And here the positive terminal of the battery is connected to the point C, and the negative terminal is connected with a jockey through a galvanometer and a high resistance box. Here you can see a galvanometer and HR. HR means a high resistance box, and this jockey is connected along with this high resistance box and galvanometer from this negative terminal of the battery, and the positive terminal of this battery is connected to the same end C, and here it is forming as a secondary circuit. Now how we are doing this is how we are doing this experiment. I will tell you how we are doing. Just assume that you are moving this jockey. This is a connection. Assume that you are moving the jockey over this wire. Over this wire means 100 meter wire. Maybe you are starting from here, jockey. You are moving like this. When you are moving this jockey along with this wire, we can see that the galvanometer deflector. The galvanometer deflector. So that what happened means, when the jockey reaches in some point, we can tell that CJ. This CJ. Now the jockey reached here. When the jockey reached on this CJ, what happened means, now you can see that when you are moving this jockey over this wire, this galvanometer will deflect. Galvanometer will deflect. When you reach some place, you can see that the galvanometer will show the zero deflection, like this. Zero deflection. So the galvanometer shows zero deflection means What happened means the potential difference across this wire and this cell is balanced. The potential difference, the voltage across this wire, here you can see 10 meters of wire. Maybe you are moving the jockey over this wire. When we are moving, maybe I reached here. Now you see 100, 200, 300, 300 and maybe 50. When I reach the point 350, this is what we can tell. Okay, 350. This is what CJ we are telling. And when I reached this 350 meter, what happened means I got zero deflection on this galvanometer. Why this galvanometer deflect zero? Because now you see the potential difference across this wire and this cell is what equal, so that we can tell the CJ is the balancing length L. CJ is the balancing length L. So now the potential difference across this wire is, we can tell that IR into L. IR means we know the potential difference formula, V is equal to IR. V is equal to IR. This is what potential difference formula, and balancing length into its length per unit. That is what we are taking. So that we can write the equation. Now the EMF is equal to IRL. What is this I? I is the current flowing through this wire. R means the resistance per unit length. L means the balancing length. So this is what about the potentiometer. Now what is happening means, this is what you have got on reading. Again we can take more reading. So whenever you are taking the reading, we will get a relation. EMF is directly proportional to the length. EMF is directly proportional to the length means, when you are increasing the EMF, what will happen? This balancing length also we will get more. That is what about the potentiometer. Now based on this potentiometer, you can see a practical comparison of EMF. Now we are comparing the EMF of two cells with a potentiometer. So that you can see that this is one of the practical. By using the potentiometer, we are comparing the EMF of two cell. For that you can see how the construction is. First you see potentiometer wire. This is what potentiometer wire C and D. Now this potentiometer is connected with the battery. Potentiometer wire is connected with the battery. This is what the battery, and a key, Now here I am putting, including on resistance. This is what the rheostat we are saying. We have one. So actually this resistance we are using to varying the potential difference. We can change the voltage, we can adjust the voltage. That's what we are using this. This is a key. So that you see the potentiometer wire CD, battery and key, it is forming as a primary circuit. So this is what primary circuit. Now you can see that this end of this C, end of this wire C, what is connected means, here it is connected like this. Okay, this is what M, this is what N, and here one cell, here another cell. Actually 6 point will come. Okay, like this 6 point. Okay, So this is M1, this is M2, this is N1, this is N2. Actually this is a DPDT switch. DPDT switch, double pole, double throw, you will tell. You can tell easily two-way switch. Actually here one switch will be there, and if you are pressing the switch this side, this cell will work. So EMF 1. If you are pressing the switch this side, this cell will work. That is what comparing the EMF. Then we will find the balancing length, and here a galvanometer is there. Along with the galvanometer, a high resistance box and a jockey is connected. This is how a potentiometer is arranged with the DPDT switch with two cells. So that we can compare the EMF of two cell. First here we are using Daniel cell and Lagrange cell we have in the laboratory. First we will put one side. So we will find the EMF 1 and its balancing length. Then what? We will change the switch this side. Now we will find the balancing length. Then comparing that is what? While comparing the balancing length, that is equal to what? The EMF. So this is how a circuit. So for that, first thing you see. So what are the things connected in the primary circuit? A potentiometer wire, CD, battery and key is connected to form primary circuit, and from the point C a DPDT switch is connected. This from the point C it is connected with the terminal M, and from this terminal LN of this DPDT switch is connected with a jockey through this galvanometer and a high resistance box HR. Now you see two cells with EMF 1 and EMF 2 which is connected M1, N2 and M1, N1 and M2, N2. So this is how it is constructed. Now how we are doing this practical means I told first we will press this DPDT switch via M1, N1. That means we will keep the switch like this. Now which battery? So from the secondary circuit this EMF, this battery is now working. Now we will find the balancing length CJ. For that we will move this jockey over this wire so that we will get the balancing length. How it means in this galvanometer it will show the zero deflection. Then we will get the balancing length. So first what we will do? Just we will press the DPDT switch towards M1, N1. Then now this secondary circuit EMF 1, this cell is active. For example, I am telling this is Daniel cell, this is Lagrange cell. When I am pressing this switch towards this side M1, N1, Daniel cell is active. Now Daniel cell is active, so EMF 1 is there. So EMF 1 balancing length CJ we are finding. So that for that we are moving the jockey over this 10 line. Here before I said we will move this over so that we will see that in one place when we reach any place this galvanometer will deflect 0. So when the galvanometer shows zero deflection, that is the balancing length CJ. So we will get a L1. Now next what we will do, we will include the M2, N2 so that now the switch is pressed towards this M2, N2 so that this EMF 2 is included in the circuit. Now we will find now EMF 2 is active. This battery Lagrange cell is active. Now again we will find the balancing length CJ. Now the balancing length we are taking L2. So from this we know that R be the resistance per unit length, I be the current flowing through the wire. So that EMF 1 is, we can tell IRL1. EMF 2 is IRL2. Now this you take 1, this you take 2. So divide 1 by 2. When we are dividing these two equation, what we will get? EMF 1 by EMF 2 is equal to IR L1 by IR L2. IR cancel, so that we will get EMF 1 by EMF 2 is equal to L1 by L2. And here one rheostat is attached to repeat the experiment for changing the value, and we are doing the experiment. We are using this so that we can repeat the experiment several times. We can do the experiment by using this rheostat. Okay, so this is how we are going to do the practical and comparing the EMF of two cells by using this potentiometer. Okay, my dear students, in this two you can study this comparison of EMF of two cell with a potentiometer. It is one of your very important question, as well as it is very helpful for your practical. Once you are coming to the school, we will take the practical session. During this practical session, you will understand more about this potentiometer, and don't hesitate to ask your doubt. You can ask me the doubt, and you can take a screenshot of this page number 109 potentiometer. In page number 110 you can see the comparison of EMF of cell with two cell with a potentiometer. Okay, you can take a screenshot of this and study this. Here the comparison of EMF of two cells with the potentiometer is one important question, and all of you go through this, watch the videos, ask your doubt. Don't hesitate to ask the doubt. Thank you all. Bye bye.